let me show you another thing to name and how to name it, okay? These are halogens, okay? When the halogen is attached in an organic molecule, like this alkane here, okay? If it's an F, we call it fluoro. If it's Cl, we call it chloro. If it's Br, we call it bromo. If it's I, it's iodo. If we have a halogen attached to our hydrocarbon, it's called a halocarbon, just FYI. Okay, so I drew a new molecule. So the very first step is we have to find the longest chain. So I'm going to count all different ways. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2. I'm making sure the longest chain is 4. And if I do 1, 2, 3, 4, if it's a 4-carbon chain, must be butane. Okay? Now, but what's on the butane? Okay, so let me number it. Now, I have something on either end, so I can start numbering either direction. Okay, now, what do I have? I have a bromo, another bromo, a methyl, and another methyl. Point one more thing out. I don't have any H's. The H's clutter my structure, so consequently, I have my H's out. Okay, so I have substituents. Remember, the side groups are called substituents. Bromo, methyl, methyl, bromo. Okay, I need to name and put them here. Okay, so I numbered my carbon, my longest chain, 4-chain, butane. Okay, I've identified my substituents, bromo, methyl, methyl, bromo. I need to put them in alphabetical order, okay? I have, what comes first, bromo or methyl? Bromo. So I'm going to put bromo before methyl. Now, how many methyl? I have, in fact, I'm going to need more room. I'm going to put bromo here. I have 2 methyls. That's di. We use the Greek prefixes for how many. We use the numbers. Where are the methyls? 2, 3. So I'm going to do 2, 3 dimethyl. But what about the bromos? I have dibromo. How many? I mean, where I have how many? 2 dibromo. And where are they located? 1, 4. 1, 4 dibromo. 2, 3 dimethyl butane. Now notice how I did it alphabetically. I didn't take into consideration the Greek prefixes. B comes before M, methyl. Bromo becomes before methyl. So I put, that's the alphabetical order. Will it change radically? It will not. But that's the convention, is you put them in alphabetical order. So the numbers and the prefixes, you ignore that when you put it in, you put it bromo before methyl. Now, let's go through and let me do one more example here, using all the stuff we've had. We'll put a really complicated molecule on and show you how to name it. So this is okay. Okay, now, this is called a skeletal model. We presume these all have H's, but sometimes it's easier to write it that way so you can see what everybody is. But you presume all the correct number of hydrogens are in here, and that's the default. If it's not something like a Cl or a Br or some other side group, you presume that there's a hydrogen. So that was the skeletal. So let me name it. The very first step is you get the parent chain. The parent chain is the longest chain of hydrocarbons, okay? So I have to count it several different ways. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. All right. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. So what's attached? 7. 1, 2, 3, 4, 5, 6, 7, 8. You double check that the longest chain in any direction, it's 8. So we have here 1, 2, 3, 4, 5, 6, 7, 8. 8 is octane. Now, what do I have for side groups? So I've got my parent chain, 8 octane. Let's number it. Let's just number it like this. I have somebody on the either end. Let's just number it like this. So it's clear. Now let's identify, let me just circle all the different substituents or side groups. Cl, this is a methyl, iodo, another methyl, here a methyl, Cl, F, and a 2-carbon chain, ethane, which would be ethyl. So chloro, methyl, iodo, methyl, methyl, chloro, ethyl, fluoro. What is first? Bromo, so we have bromo, numbers and prefix, okay? We have ethyl comes before fluoro, chloro, we have chloro, we have, I'm gonna have to move him, octane, we have bromo, chloro, ethyl, fluoro, and methyl. Octane. Now we need to put in number and how many? How many chloros? Bromos rather. Let's start with bromos. So we have 1 bromo here, okay? So where is he? We can just do 4 bromo. There's only 1, okay? How many chloros? 2 chloro, so they're 1,7 dichloro. Let me move 4 bromo. 4 bromo. 4 bromo. 1,7 dichloro. Remember the number 7, 1 and 7 are positions. Ethyl, we have only 1 ethyl, so it's 6 ethyl. So a comma here. Actually, let's do it this way. Leave it like that. 6 ethyl. And fluoro, I have 1 fluoro, 8 fluoro. How many methyls do we have? Here a methyl, there a methyl, everywhere methyl, methyl. We have methyl, methyl, methyl. So we have, let me put it right above it. We have trimethyl. And where are the trimethyl, where are they all located? 3, 4, 6. So it would be 3, 4, 6 trimethyl octane. So the way to approach this is very, very systematically. Identify what's the longest chain, the parent. Okay, what are the names for all these side groups? Then where are they located? So like this is on the number 1. This chlorine's on the number 7. Then you put them in alphabetical order by their root word, bromo, chloro, okay? Then if they're, like for instance in chloro, you have 2 chloros, so it's dichloro. Where are they located? On the 1 and the 7, okay? And that's how you write these molecules.